My name is Ethan Fosse. I'm a sociologist and I'm the Associate Director of the Data Sciences Institute at the University of Toronto. And I have many tracks of research in the areas of computational social science as well as temporal models. For this project, we were interested in developing innovative methods for analyzing social change. And as part of this project, we were interested in clustering societies, neighborhoods, institutions, and seeing how they evolve through time in these clusters. This project introduces a unified framework for socio-spatial temporal clustering. The idea is that we analyze how different social, political, and economic entities change over time. These entities can be neighborhoods, communities, states, they could be schools. The idea here is that this approach allows for both static and dynamic group definitions. This helps us to understand better shifts in political polarization, cultural values, and neighborhood transformations. Traditional clustering methods assume fixed groups that don't change over time. This makes it difficult to track real-world social change. Our framework incorporates time explicitly, and it allows for the definition of clusters to change over time, while entities are also allowed to shift in and out of clusters. The idea here is that it allows us to better understand social and political trends, and potentially this can inform policy, urban planning, and even education equity efforts. We learned three main aspects of social change. First of all, social change is more fluid than previously thought. So for example, we look at political polarization in the United States, and we find out that political shifts across states are not just about switching from red to blue states, but they involve deeper changes in ideology and what it means to be a red state or blue state. The second finding is that cultural shifts are not uniform. So we use global survey data to examine cultural attitudes, and we find that countries follow different paths based on historical, political, and economic factors. Finally, we've developed this new framework, this new method that we call bounded dynamic clustering, and this is useful for identifying key transitions. The core idea here is that by restricting the number of movements that some entity is allowed to make across clusters, so for example, maybe a state is only allowed to transition once or twice from a red state to a blue state, we can highlight the most significant, meaningful changes